In this demonstration today, I'm going to talk about using IoT to enrich enterprise data. The goal is to move beyond point-of-sale analytics, to use IoT data to make better business decisions. My name is Martin Madsen. I have a PhD in experimental physics and about 15, 16 years worth of experience working with data in a variety of different forms. In this demonstration, we're going to focus on an imaginary company. This is the AdventureWorks cycles that comes as the demonstration database as part of Microsoft SQL Server products. The company, this imaginary company, has 4 different sales categories. They primarily sell bicycles, but they also sell bike components, clothes, and a variety of different bicycle accessories. We're going to envision what this company could potentially do as an IoT project that would lead to a positive return on investment. They want to create an IoT project that will tell them something useful about what they're doing and how their customers interact with their products. So let's drill down a little bit into the AdventureWorks data set and look at the kinds of things that we could use as an IoT project. Their primary sales are bicycles, but perhaps our users are using different bicycles. And so I don't really want to focus on bikes. So let's drill into the accessories category and see what potential there is there. Tires and tubes, hydration packs. It turns out that helmets are a reasonable place to look for a potential IoT project. Users are wearing helmets, hopefully wearing helmets as they're riding their bicycles. If they change bicycles, they're still using the helmet, so it's telling us behavior about the people themselves. Helmets also have the capability of telling us what's happening with the people. For example, if they're in an accident or a crash, the helmet is going to be a part of that. So we're going to envision the AdventureWorks company that takes what has been their traditional bicycle helmet, and they're going to re-envision it now as an IoT project. What if the helmet were now connected? They add in a GPS receiver so that the helmet knows its latitude and longitude, and also has a clock as a part of the GPS receiver, so the helmet knows what time it is and where it is. They're also going to add in an accelerometer onto the helmet so that they can measure these impacts or crashes, and they'll add in a mobile transmitter, something like the AT&T IoT starter kit, so that the helmet can continuously talk with the mobile networks as long as there's, of course, coverage. So as soon as the user turns on the helmet, it starts recording these things, and it lasts as long as the user has the helmet on, and as long as it has battery charge, of course. And we're going to simulate what this IoT data could potentially look like. And we're measuring latitude, longitude, time, and accelerometer readings every 10 seconds while the helmet is, this imaginary helmet is on. So we've already taken care of the first couple of steps in an IoT project. We have the things, we have the helmet, and we've talked about what kind of connectivity we're going to use. The latter part of IoT projects are collecting the data and then performing analytics on that data so that it can lead to actionable insights. And there are 2 different types of streams, data streams, that lead to different types of actions. The first type is a hot data stream. These are the types of real-time alerts that could come from the system. We could watch the helmet, and if there is, for example, an outlier in the accelerometer that perhaps there was a crash, we could tie that into a call to the user to find out if they're okay, or a call to emergency services letting them know that something's happened to one of our users. But there's also a cold data stream, and this is a separate type of data. Instead of watching what's happening with users as real time happens, we gather tens, hundreds of millions of data points. And from those historical data from this IoT project, from this IoT helmet, we can start to develop patterns, understand patterns and trends in the use of the products. And that leads to a different type of analytics and action that are more tightly connected with business decisions. And in this demonstration, we'll talk about 3 stories of different types of business decisions that could come out of an IoT project. As a quick review of the hot data stream, because this is an important part of an IoT project, we're going to simulate what would happen if we use, for example, the Microsoft Azure stack. So the device is transmitting data, and we collect that data on the cloud using the Azure IoT Hub. And then from that, we route the data using Azure Stream Analytics into a Power BI dashboard. And this gives us a real-time monitoring of all the bicycle helmets and what's happening with them. And we develop a simple dashboard that might look like this, where we have a geographical point. This is the GPS coordinates of where the helmet's at. We have an accelerometer reading and a cumulative distance, how far the bicycle user has traveled. So in this particular trip, the user has been start and stop about a 10-minute trip, give or take. They've gone a couple kilometers, and there's no abnormal accelerometer readings. That's all within the range of normal. The data are simulated, and so the GPS coordinates don't map to real-world locations. And so I essentially used a random walk to simulate what's happening with our users with a known step size that varies a little bit based on the user and the time of day. So this is the hot data stream, but we're actually more interested in what happens with the data if we look then at the cold data stream. So instead of just routing the data from Azure Stream Analytics into a dashboard, we're also going to route the data into a cold storage. And in this case, we imagine using something like Azure Blob Storage or a NoSQL database. Some kind of storage where we can amass large amounts of data. In this case, we're going to amass about 190 million data points from about 670,000 different trips that our users are taking. So looking instead at the cold data stream, once the data have collected on Azure Blob Storage and we have this group of data, we need to do something with it. The first step is probably going to be some kind of intermediate processing. And in large data stores, it's typically going to be done via a MapReduce project using one of the Hadoop tools. In this case, we have a data factory script that runs a couple of Hive scripts on Hadoop on an HD Insight cluster that's called up from the Azure Stack as needed. And then once we've done the intermediate processing, we store it in a SQL Server. And once it's there, it can be joined with existing enterprise data. So not only do we have the information from the IoT device itself, but we've connected that to our other information, the other sales and information from the customers, the region in which the customer is in, when they bought the helmet, how many helmets have they purchased, what are the other objects what are the other products that they purchased from the company. Combining these data sets together then, we could create an SSAS tabular model or a Power Pivot model that will enable us to slice and dice the data and do more sophisticated analysis, not just on the devices themselves, but combining those with the enterprise data. And this is where we're going to focus our stories today. The three different stories are going to be first a time tracking story. So since we have data about usage from the time that the user turns the helmet on until the time that the user turns the helmet off, we want to ask how and when are the customers using their helmets. And this could lead to a potential enterprise question as to what should the product cycle be. So once we know the time frame of usage of these devices, it could tell us a little bit more about when we should be cycling products, or at what time frame is the natural time frame to get our customers more interested or re-engage with the customers. The second story is talking about the reliability or the accident data. So we have accelerometer readings from these helmets, and so we can tell how often these helmets get into a crash. This is akin to knowing something about the reliability of a product. When you know that the product has a malfunction, and the only way a bicycle helmet could conceivably malfunction, apart from a strap breaking or something, is if it's in an accident. At which point in time the helmet should not be used again, depending if it's in a severe accident, and the user should replace their helmet. So we're talking about replacement cycles for this product. And that could lead to questions about either a warranty, thinking about presenting the helmet as guaranteed. If you get in an accident, we'll replace it for free. Or another possibility is to think about the product as a service as opposed to as a single-time purchase. Instead of the users buying a helmet, a single instance of a helmet, they're buying access to helmet for as long as they live or as long as they have the product itself. So if they get in an accident, the company will replace the helmet so that they always have a helmet with them. So there's a potential for changing the business model from a single purchase to the product as a service. And then finally, we could use the geographical data to ask the question, where are our users, where are our customers using the product? And that could tell us about where we should be focusing our efforts in terms of expanding sales or market share in a different geographical location. So instead of looking simply at where we've sold the products to, and we know that from the shipping information from the enterprise data, but where are these people actually using the products, and are there groups or communities that we could tap into and expand the market that way? So those are the stories that we're going to talk about. So starting with the first story, when and how are our customers using the product? If we look at the traditional enterprise data, essentially all we've got is the point of sales. When did we sell the helmets? And we know that over the course of the 2 years in the sample database, from 2007 to 2008, we have a total helmet sales. We also might have a customer survey. For example, in the AdventureWorks database, they've asked their customers what their average commute is. And so we have a listing of the different possible commute distances from 0 to 10 miles and how many helmets we've sold to these different customers, the vast majority being on a short commute. But we don't know if they're using the bicycles to make those commutes, or is this just a standard commute for automobile? We don't know any of those things from the traditional enterprise data because we don't have actual usage. And this is where the IoT can enrich the enterprise data. So the first set of data we're going to look at from our IoT simulation is the when do customers first use their helmets? When is the first turn on time? We know when we ship the helmet to the customers, and then we can just track how long does it take for them to turn it on. And we can plot, so on this plot we're showing the days since ship date on the horizontal axis. And on the vertical axis is the number of customers that have turned on the helmet on that day. So there's a couple of customers that obviously have fast shipping, that they're turned on their helmet only 3 days after we shipped it to them. But there's a bulk of the customers that within about 2 weeks, 11 to 17 days, they have received their helmets and actually activated it and turned it on, done something with it. And this might say something about how we want to look at shipping channels and how we want to engage the customers. For example, if they haven't turned on their helmet after a couple of weeks, we might send them a reminder saying, hey, you just purchased this from us. You should go for a bike ride, and engage the customers a little bit more directly. So beyond that, we can track how often our users are using their bicycle helmets, how often they're turning them on, over the course of the lifetime of the product. So what I've done is shifted all of the dates so that we're tracking customers from the day that they first turn on and use their helmet. So on the horizontal axis, we've got days since first use. And this is tracking about 15 years of data on this horizontal axis. And I've broken it up into 30-day periods. So every 30-day period, how long did you use your bicycle helmet? And we have 4 different categories. We have the first category, which is the blue category, users that have less than 1 hour use in a month. So these are very light or casual users. And we can see that over time, initially we have about 600 people who are using their helmet about once a month. And over the course of time, that drops off. I simulated what might be a natural product cycle, that people are excited about the new product and use it a lot, and then over time, the usage just tapers down. The second category is users that use their helmets between 1 and 5 hours a month. So these are people who are riding about an hour a week, give or take. And those are the majority of our users. About half of the total number of users initially are using their helmets about 1 to 5 hours a month. And then we have heavier users, the gray line, which is people who are using between 5 and 10 hours a month, and then the die-hard bicyclists who are using their bicycles their helmets more than 10 hours a month. These are people that are biking 3 and 4 hours a week. So these are pretty hardcore cyclists. This by itself can segment our customers, and there might be interesting ways in which we could market to and engage with, especially the hardcore users, people who are biking more than 10 hours a month. But I'm actually interested in the idea of a natural cycle, the fact that the customer's usage is dropping off over time. So we instead plot the percentage of the active users over as a function of time. So early on, there's 100% of the active users since they've all turned on their helmet and gone on a bike ride. And then over time, this is the drop-off that we simulated, that people are just stopping using their helmet. And over the course of the 10 years or 15 years, it drops down to almost zero. But zooming in on the initial data, the first 2 years worth of data, we can see that the simulation shows that there's a slow drop-off for the first year and a half or so. We're losing a few customers. But about a day 480 or so, after about a year and a half, the drop-off starts to steepen. And we end up losing another 10% of our customer usage over the course of a couple of months. And this would be the ideal time to refresh the product, to get the customers re-engaged. As we've lost about 20% of the customers using the product, this is the point where we could envision a new product release. And with the new product release comes a new engagement cycle, a new interest in the next generation of bicycle helmets, or a re-engaging in the idea of healthy living and cycling, in which case we could up the active users again and re-engage the customers, as well as engage them in a new set of purchases, which is good for the bottom line of the company. So by looking at IoT data, we can now talk about a natural lifespan for a product, that it looks like 2 years is about the right time frame for product re-releases to keep the customers engaged. So we've joined the marketing data, we join what we know about the customers along with how they're actually using the helmets to be able to say something about how to design our product life cycles. The second story is the accident story. How often are customers getting in accidents, need to purchase new helmets? How should we design a warranty? And with just traditional enterprise data, we don't really have any idea how to think about customer usage with multiple helmets. We can look, for example, at the number of helmets that each customer purchases. You could imagine that after getting in an accident, the customer needs a new helmet, so they purchase a new helmet. But the vast majority of the customers only purchase one helmet, and at least according to our existing enterprise data. We can zoom in on the 2, 3, 4, 5, and 6, and we have a couple hundred people that have purchased more than one helmet, but we don't know why. They're purchasing a second helmet for another person in the family. Did their first helmet get in an accident? We don't know. So this is another example where the IoT data can enrich the enterprise data to tell us about how we can change our business model and how we can add in components to the business model to improve the bottom line, to improve our return on investment. So what I'm plotting here is the IoT data. This is again simulated IoT data. On the horizontal axis is the days since first use. This is the same axis as previously, but now on the vertical axis, what I'm plotting is crashes per customer. So this is the fraction of customers using the bicycle that have had some kind of accident or incident that is registered on their accelerometers on their bicycle helmets. The first type of accident is a minor crash, and this is the blue dotted line. This is, for example, tapping your head against the wall or dropping the helmet a little too hard after you've taken it off. These are not serious crashes, they're not damaging the helmet, and they're not an issue that would bring up helmet replacement. And over time, this grows after a couple of years to about 8% of the total customers have this kind of recorded minor crash. We're more interested in the serious crash and a major crash. Serious crashes are falling off the bicycle, and a major crash is something like being hit by an automobile. And those are the kinds of scales that we're looking at, the thresholds on the accelerometer readings. So the orange curve shows that over the lifetime of usage, about 10% of bicycle users have some kind of serious crash. They fall off the bike or run into a wall or, and slightly embarrassingly, a parked car or something like that. And then about 1% of the users have a major crash. And this is about the same fraction of people who are biking many, many miles. And so the number of crashes per kilometer ridden is not, it's only about one crash per every couple 100,000 kilometers ridden, but it's going to happen. These are going to be crashes. We can add those two the serious and the major crash fractions up, and that gives us the yellow line. And these are the helmets that should probably be replaced, especially after they've gone through this kind of serious or major incident. And that tells us that about 11% over the lifetime of the helmet, about 11% of helmets are going to need to be replaced. And that tells us what it would look like if we wanted to offer a warranty or if we wanted to change the way in which we sell helmets from being just selling a single product to selling a warranty or the product as a service. If the additional cost of doing this is greater than the 11% times the production cost, how much does it cost to make the helmet, then the return on investment is going to be positive, because only 11% of the helmets are going to need replacing. So now that we have this data, we can make this serious consideration to engaging the users in a different way. Not only in using the hot data stream and providing them alerts or checking on their status, asking, are you okay after having these kinds of accidents? But we can also think about changing the business model in a major way, because we know how often we're encountering these kinds of crash replacement worthy incidents. The last story is to look at where our customers are using their helmets. From traditional enterprise data, we know where we sold them, and so we could look at sales, for example, by country over the course of the 2 years that we have helmet sales data, and we see there's a nice positive growth in all of the different markets. But we don't know if these people are actually using the helmets. We don't know if they're using them in the places where they've purchased them. We don't know what they've done with the helmets in those countries. So this is, again, where IoT comes into play, where now, because we have GPS data, we know where our users are riding their bicycles. And we know how far they're going. And so in this set of data, what I'm looking at is the average distance traveled per person by country. And then I've broken it down by year in the color gradient. So in the lower left-hand corner, I'm showing that from 2007 to 2017, 10 years worth of IoT data, the average distance traveled per person, there's an increase, which corresponds to the increase that happens from 2007 to 2008 as more users are buying the bicycle helmets, and we have a greater average distance traveled. And then the global average from our IoT data actually steadily drops over a course of time because we don't have any additional helmet purchases. We only have the 2 years of purchases happening. So there's the same downward trend in each country, from Australia through the United States. But that doesn't tell us how much this is compared to all the other riders. We know we could scale this average distance traveled per person by our measured average. But what if we had more than that? What if we knew, for example, what the market average was for the number of kilometers traveled per person in each of these countries? So we're going to rescale this is just the same data. I've just rescaled it down so that I could add in a fictitious market average. So if we knew what the market averages were for each of these segments, we can now compare what our riders are doing to the market average, which will tell us something about the engagement of our bicycle riders, of our customers, compared to everyone else that's going on. So in this picture, we can see that we have a reasonable fraction of the Canadian market. And it would be even more useful if we could do a market share. So let's look at the fraction of our rider distances to the market averages. So this is our helmet customer usage versus the market average, and this gives us a ratio. And now we can see that not only do we have a fairly large market share in Canada, that our riders are riding a significant portion of the total market average, but it's growing. And over the last 4 years or so, it's become incredibly strong, that we have a strong ridership in Canada. Similarly, the ridership in France is growing over the course of the last 10 years, and there's a slight growth in the United Kingdom, whereas we can see in Germany and Australia, the fraction of riding that our customers are doing is dropping compared to the market averages. So now that we know how our customers are doing compared to the market, we can focus our sales, we can focus our international efforts on concentrating in these areas where we have active riders and improve our sales and our customer engagement in those areas. We could drill down further, and because not only do we have by country, but we also have by region inside the country, we could drill into the United States and see we have an active ridership in Oregon and Washington, and then use that, leverage that information to improve our customer engagements in those areas. So in summary, we have we've envisioned an IoT project where we've got the idea that we've changed one of our products from helmets to an IoT helmet, where we've connected it to our network, and we can now take data and run analytics. We are primarily interested in the cold data stream, where we focused on the patterns and trends that were gathered over tens and hundreds of millions of data points from these simulated users. And we can now make real business decisions. The actions that we can take based on the IoT data, we can improve the ways in which we engage with customers and improve the ways in which we manage the business and improve the bottom line. The goal in the end is to improve our return, is to have a positive return on an investment and to improve the business models of the company to improve the bottom line. And this is happening in the real world. There are real companies that are doing this same type of data collection. 3 examples are Rolls-Royce, who have changed the idea of aircraft engines from selling engines to selling power as a service to the airlines because they're tracking usage and they have long-term data information. The ThyssenKrupp elevator company is doing a similar thing, working with Microsoft in creating the elevator as a service, tracking the usage and the maintenance schedules of their elevators. And even a company like Tesla, because they have information about where their cars are going, where and what they're doing and how they're performing, are able to use the cold data stream to make improvements on the ways in which their cars interact with the environment. And then they actually continuously push out improvements and changes to the ways in which the device operates, and making real-world improvements based on over-the-wire updates, hot updates of their system. Thank you for your time. If you have questions, comments, or further conversation, I'd be interested in talking with you, and you can find me on LinkedIn. Thank you.